Hi, in this video we're going to look at the total amount of interest paid over a given time period. Let's look at the example. You'll see what I mean. We got a 30-year mortgage of $300,000 at a nominal rate of 3.6% compounded monthly. It's being repaid with level monthly payments. And we're asked to determine the amount of interest paid over the second 10-year period. Okay, so we got a monthly effective interest rate in this case. They were giving me a nominal interest rate of 3.6% compounded monthly, so that's equivalent to a monthly effective interest rate of 0.003. So let's start with that. And now we can look at, we've got all the information here. We can look at what the amount of the monthly payment is, for instance. The $300,000 is the present value of all the payments. So let's compute the level monthly payment first with this equation. Use your TVM buttons and you'll get that the amount of the payment is $1,363.94. Okay, so now the second 10-year period, because we've got these monthly payments, 30 years, the second 10-year period actually extends from time 120 to time 240. So over that time period, the total amount of the payments that are going to be made over that time period would be, that's 120 time periods. There's 120 payments between those two time periods. So I need to multiply 120 times the amount of each of the monthly payments. And so I get a total of the total amount of payments during that time period would be the 163,672 number. And then we look at the amount of principal that's repaid between those two time periods. So the total amount of principal repaid would just be the difference between the balances at those time periods. The balance at time 120 and the balance at time 240, you're paying it down. So the balance at time 240, you owe less at time 240 than you did at 120. And you take the difference between those two balances and you'll get the total amount of principal that was repaid during those two time periods. And that number ends up being $95,828. I'm going to focus more on the calculation of these numbers in just a second. I just want to kind of get through the idea first, the big picture idea. So you calculate the total amount of the payments, and then the total amount of principal repaid is an easier calculation because that's just the difference between the balances. We saw all of this in the learning video for this material. And then the total amount of interest paid then over that time period, well, you take the total amount that you paid, which was that 163,672 number, and you subtract off the amount that was repaid in principal, and then that difference would be the amount that was paid in interest. So my final answer is going to be the 67,844 number. Now let's talk about how to get some of these numeric values. I wanted to give you the big picture first because this is really a very short problem once you learn how to use your calculator. So this is really an exercise on using the TVM buttons on your calculator. Let me show you what I mean by that. Okay, so now let me clean up the video a little bit and show you these numbers that I got. The first number that we would be trying to calculate is this amount of the payment number. So the TVM buttons, this should be no problem here. You should be able to calculate what the payment amount is. I've listed what the keystrokes would be to calculate that payment. So you make sure your calculator is in the end mode. 360 is going to be the cap in value. The end value is going to be the number of payments. It's a 30-year mortgage with monthly payments. That's 360. The I/Y is the periodic, in this case, monthly effective interest rate as a percent. So that's 0.3. Present value of 300,000. Future value, we're going to pay it off after those 360 payments. So the future value is going to be 0. And then we compute the payment. Now, the payment does not come out as exactly the $1,363.94. I think I got a payment of this amount, this long decimal. And so I didn't change the payment to $1,363.94. I didn't change that in my calculator. I just left that payment in my calculator. And then I multiplied that payment times 120. So I didn't get exactly 163,672. I got this decimal value in my calculator. And that's fine. I just stored that value somewhere in my calculator. But when I wrote it down for you in the in the slide, I didn't keep all those decimals. I just cleaned the numbers up a little bit. But in my calculator, I didn't round anything off in my calculator. I just stored the buttons as they are there in the register on the calculator. Okay, so now we move on, and I've got the total amount of payments. That was easy enough. I compute the payment and then multiply that by 120. I store that somewhere in my calculator. That's easy enough. So now let's talk about the balances, though. How you would calculate the balances at time 120 and at time 240 in this context where we have these level monthly payments. It's very easy to do once you catch on to it. Now there's, as with all the cases, when you compute balances, there's retrospective calculations and prospective calculations. I personally, in this type of problem, when I'm computing these balances, I personally look at the retrospective calculation, but I'm going to show you both. So retrospectively, now what do I mean by retrospectively? Well, I'm at time 120, and I look back retrospectively from time 0 up to time 120. So what I'm wanting to do there is compare the balance at time 0 with the balance at time 120. And this is how I would do that. The balance at time 0 I think of as the present value. The balance at time 120 I think of as the future value. The payments are capital C between those two time periods, and there's 120 time periods between those two values. And so technically this is what I'm doing to retrospectively calculate the balance at time 120, but it's easier than what that expression, that equation there, it's easier than what that equation is suggesting, because look, I've already put all these numbers in my calculator. I'm still in the end mode. I still have 360 as the cap in value and so forth. I've got all of those numbers in my calculator. I computed what the payment was, so that's where I'm at right now. And now if I want to know what the balance is at time 120, all I do is change the end value to 120 and compute the future value. And that's it. So everything is already in the calculator. I don't have to re-put anything else into the calculator. And now the one thing that I want you to recognize, though, is that look at the equation that I have there that's relating the balance at time 0 with the balance at time 120. And you can see from that equation that the capital C value and the capital B sub 120 value should agree in plus or minus sign. And the way that I input things in my calculator is with a negative payment. The payment that's in the calculator right now, if you follow the keystrokes that I have, the payment is in there as a negative 1,363 point such and such. And then when I compute the future value, it's going to come out with the same plus or minus sign, because I look at the equation and I see that the payment, the cap C and the cap B20 both have a plus in front of them. So if I put the payment in as a negative, then the cap B sub 120 value is going to come out as a negative. And sure enough, when I go through these keystrokes and I change the end value to 120 and I compute the future value, the result is a negative that's coming out in my calculator as a negative 233,107 number. And I'm just going to write that then as I'm going to recognize that the balance then, that's telling me that the balance at time 120 is $233,107 and plus some change there. So I still owe, after 120 payments, I still owe on this original $300,000 after 120 payments, I still owe $233,107 on that. And now what do I do to get the balance? So take that number and store it somewhere. And now how do I calculate the balance at 240 times 240? I just put 240 in for the end and I compute the future value. Again, same principle here. The result there will be this negative number because it's going to come out as a negative because the payment is in there as a negative. And I ignore the negative sign, and this suggests, or this tells me that the balance at time 240 is 137,279 plus some change there. Okay, so that's the retrospective. That's how I would actually do the problem. And again, it's a very quick problem on the calculator. This entire problem is very quick if you're used to working on the calculator with the keystrokes on the calculator. Let me go back now and show you how you would do this prospectively, how you would calculate these balances at time 120 and 240 prospectively. So let's say that we're back to the original part of the problem where we just computed the payment. So we just got the payment computed, and now I want to do a prospective calculation to calculate the balance at time 120. Well, prospectively, I'm at time 120, and if I'm looking prospectively, I'm looking into the future. So I'm really relating the balance at time 120 with the balance at time 360. And this is how I would do that. I would have the balance at time 120 as the present value and the balance at time 360 as the future value. Now, when I do this, there's 240 periods between time 120 and 360. So I would, in order to use the keystrokes here, I would type in, even though I'm calculating the balance at time 120, I'm doing it prospectively, and from time 120 to 360, there's 240 payment, so I would put in a 240 for N, and I'm trying to calculate the balance at time 120, so that's 120 is a present value. It's the earlier balance, it's the present value. So that's what I would do here. Now technically look at the last equation there where I'm relating the balance at time 120 with the balance at time 360. The balance at time 360, you just paid off the loan. The balance at time 360 is 0. But look, I already have that in my calculator because above that you see that I have a 0 already stored as the future value. And so so I've already got that in the calculator. I didn't have to put anything else into the calculator. It was already there. And notice that a 0 times the v to the 240 is just 0, so I can just leave that term off. And really what I'm calculating is the balance at time 120 is the present value of the remaining payments, and the present value of the remaining payments is the cap C, the payment amount, times an A angle 240, since there's 240 payments remaining to be made there. Okay, when I go through the keystrokes here, no surprise, I get the same result as I got before, that the balance at time 120 is this 233,107 number. And then if I want the balance at time 240 prospectively, I'm looking forward in time. At 240, you only have 120 more payments to make, so I would change the N value to 120 and then compute the present value, and I get the same as I did before, that the balance at 240 is 137,279. So either way, I get these two values as the balances. These two values are my balances at times 120 and 240. Take the difference between those two values, and that'll give you the amount of principal that's going to be repaid over that time period. And then I want to subtract that amount of principal that's being repaid over that time period from the total amount that I paid over the period, which is subtract the total amount of principal repaid, the $95,828, from the total amount that I paid, which was the $163,672, and that's where I get that final answer of $67,844. So again, this is not a hard problem as far as once you learn how to use the keystrokes on your calculator. This can be done in a matter of just a very few minutes. Okay, I will see you in the next video.